Okay, reflection in the x-axis. Now this says the graph of y is equal to minus f of x can be obtained from the graph of y is equal to f of x by reflecting the graph of f of x in the x-axis. Now when this is done, any point xy on y is equal to f of x is going to map onto the point x minus y on y is equal to minus f of x. In other words, whenever you reflect a point in the x-axis, the x-coordinate is going to remain the same and the sign of the y-coordinate changes. Example 45. Now, example 45 says the curve shown in the diagram is y is equal to f of x. We're asked to sketch the graph of y is equal to minus f of x. Now, as we previously stated, whenever we can obtain the graph of y is equal to minus f of x by reflecting the graph of y is equal to x in the x-axis. So for starters, the x-axis is my mirror line. Now, one way to do this is to obtain some points or some coordinates on y is equal to f of x. So coordinates I'm seeing are like minus 3, 9, minus 2, 4, minus 1, 1, 0, 0. These are just some points I'm seeing on y is equal to f of x. Now, these points are going to become minus 3, minus 9, minus 2, minus 4. So the x-coordinate remains the same and the sign of the y-coordinate changes. And of course, 0, 0 means 0, 0. All right, so we can start by plotting some of these points. So we have minus 3, minus 9, which is here, minus 2, minus 4, which is here, minus 1, which is here. The origin remains the same. So whenever we reflect in the x-axis, a point on the mirror line always is invariant. In other words, it does not move. 1, 1 becomes 1 minus 1. 2, 4 becomes 2 minus 4. And 3, 9 becomes 3 minus 9, which should be remembered here. So all that remains now is for me to sketch this graph. All right, so I'm just try and do the best that we can. It's a freehand sketch because, of course, whenever you're doing a curve, just sketching. All right, something went wrong, but we can fix it. All right, so here and here. All right, so we had a point out of line. As I said, it's something we can correct. All right, so this is the graph of y is equal to minus f of x. And again, we can obtain the graph of y is equal to minus f of x by reflecting the graph of y is equal to x in the x-axis. All right, reflection in the y-axis, the graph of y is equal to f of minus x can be obtained from the graph of y is equal to f of x by reflecting the graph of y is equal to f of x in the y-axis. Now, any point xy on f of x becomes minus xy on f of minus x. So in other words, any point, in other words, if I have a coordinate on f of x, I can get the coordinate on f of minus x by changing the sign of the x-coordinate and the y-coordinate remaining the same. Let's have a look at an example. And also, we must just remember, it's simply a reflection in the y-axis. Now, the curve, example 46 says the curve shown in the diagram has equation y is equal to f of x. We're to sketch the graph of y is equal to f of minus x. So, of course, we know by now that to get the graph of y is equal to f of minus x from y is equal to f of x, we must reflect y is equal to f of x in the y-axis. So the y-axis is now my mirror line. Now, one way you could do this is by obtaining points on the graph of y is equal to f of x and simply changing the sign of the x-coordinate to get the corresponding point on y is equal to f of minus x. That's one way to do it. You could measure it, and a similar thing, measuring, and this is the idea of measuring. The idea of measuring is that whatever is the distance from the mirror line to a point on the object, it's the same distance from the mirror line to a point on the image. So another way you could have done it is measuring. All right, but I don't have time, so I'm going to just do a rough sketch. All right, so if I do something like this, all right, so in other words, if I reflect the top half which is on the right is going to flip over to the left hand side, and the bottom half which is on the left is going to flip over to the right hand side. And of course you want to try and see if you can be as accurate as possible. So if the black one is the graph of y is equal to f of x, the blue one would be the graph of y is equal to f of minus x. So the graph of y is equal to f of minus x can be obtained from the graph of y is equal to f of x by reflecting the graph of y is equal to f of x in the y-axis. All right, example 47. All right, let's erase what we're seeing here before we do the example. All right, example 47 says the equation of a curve is given by g of x is equal to 2 into x plus 1 squared minus 3. Starting with the graph of f of x is equal to x squared, describe clearly the transformation that will give the graph of g of x. Hence, sketch the graph of g of x showing all the movements of the graph of f of x is equal to x squared. All right, so the first movement will be, so here I have points on the graph of y is equal to x, sorry, f of x is equal to x squared. Now, the next thing is for me to draw the graph of f of x plus 1. Now, the graph of f of x plus 1, you can obtain the graph of f of x plus 1 from the graph of f of x by moving the graph of f of x 1 unit to the left. Now, whenever you do that, you're going to decrease the x-coordinate by 1 while the y-coordinate remains the same. So this is going to become minus 4, 9, minus 3, 4, minus 2, 1, minus 1, 0, this is 0, 1, 1, 4, and 2, 9. So I decrease the x-coordinate by 1 and the y coordinate remains the same. So in other words, everything just simply move 1 unit to the left. Everything simply move 1 unit to the left. All right. This comes here and this comes here. All right, so this is the graph of f of x plus 1. All right, so next is 2 times f of x plus 1. This is a vertical stretch with a vertical stretch by a factor 2. The x coordinates are going to remain the same. The y coordinates increase. You multiply the y coordinate by 2, so this is minus 2, 18, minus 3, 8. So vertical stretch, factor 2, minus 2, 2, minus 1, 0, 0, 2, 1, 8, and 2, 18. All right, so some of these points I'm guessing are not going to hold, but minus 3, 8, that will hold. So minus 3, 8, that will hold. That's here. Minus 2, 2, that's going to come here. 0, 0 is minus 1, 0. That's going to remain. 0 comes 0, 2. And 1, 4 is going to become 1, 8. That's here. So those points will hold. All right. And this is a vertical stretch. All right. This is a vertical stretch. All right. And this is the graph of y is equal to 2 x plus 1 square. All right. And then lastly, all right, let's look at the final step of this transformation. Now the graph of g of x, which is 2 times f of x minus 3. So that's a vertical translation of 3 units vertically downwards. So the x coordinates are going to remain the same. The y coordinates are going to decrease by 3. So this is minus 2, 15, minus 3, 8, minus 2, minus 1, minus 1, minus 3, 0, minus 1, 1, 5, and 2, 15. That's a vertical translation of 3 units. So it's 3 units vertically downwards. So to get my final graph, I'm going to pull the other graph 3 units downwards. So this point is going to end up here. All right. This point is going to end up here. This point is going to end up here. This point is going to end up here. And this point is going to end up 1, 2, 3, goes 3 units downwards. It ends up here. All right, so let's see if we can get a sketch, get our final sketch. All right. All right. And that green graph is the graph of g of x which is